So today we're gonna go back to F cluster as always. I want to fix some stuff. Yesterday we worked a lot over JS docs, and today I wanna fix a lot of things. And let's see what we can do today. Okay, I wanted to start from something very simple. Like here, for example, in my issue list I had rewrite recipient type to be affect data instead of interfaces. Okay, so right now we have cluster src recipient type. Okay, right now those are interfaces, but I want to move those to affect data. And I always thought, where is actually recipient type as an alias used? Let's see, find our references. Okay, there are indeed some, yeah, those there are used when registering the recipient. Okay, that's fine. Okay, so let's start here. Okay, recipient type. Here we go. Okay, so let's start by importing import as data from fact data. Import, maybe, not import. Import. Okay. And I want to change this to be export class entity type of msg extends message.message.any extends data.class, and we'll move all of data.tagged class, maybe tagged class, yeah. And we want to provide the tag, which is for now entity type. And then we have the name of the entity and the schema. Okay. Here we go. Okay. And this is the first one. And we want to move all of those into this kind of syntax and also rewrite the constructors and eventually move everything to FT data. Okay. Same goes for topic type, export class, topic type, which is what present entities that can live on multiple pods, extends message any extends data dot tag class of topic type. Okay, and those are the properties. Okay, now we have rewritten those using data class. This is the same thing. Okay. Oh, hi, Mike. And then we need to change make entity type, because this now doesn't make any sense. So this is return new entity type, and we have the name and the schema. And unfortunately, we have to cast the schema as any. I don't like as any, but the thing is that I don't either want this type to care about the encoder type, so that's why I cast that. And the same goes for return new topic type, and we have the name and the schema needs to be casted. As in. Okay. That's it. Okay. And now, ideally, if we run all of our tests, nothing should have been broken. Oh, I need to start. How is it called? Oh, those works. Okay, everything seems okay. Cluster PG is not working because it's not started the service. Yeah, enough RN time. Okay, that's fine. That's because I have shut down my test container service right now, so that's fine. Maybe I can start that. Okay. So we can run those again. Applications. Okay. Docker. Okay, Docker is now started. So ideally, if I run again, now with Docker started, all of those should be running. Okay, they are now. Perfect. Okay. Okay, now that the recipient type are classes, what I wanted also to look for is to customize how the hash and equal works for the entity type, because I wanted them to be referred just by the type and the name. I don't care about the schema. So the schema is something that I don't want to be inside the equals implementation and the hash implementation of the type class. I just care about the name, which is basically the identifier. And so what I'll do is something along the lines of checking out type class implementation, root to definition. Let's see how Hefek does that. Okay, so we have here the modules, perfect. Packages, cluster, node modules, effect, data, and sorry, src data, not from here, but we should have src data, internal data, bcd data. Okay. Okay, I need to, yeah, hash symbol, equal symbol. Yeah, I need something like that. Structural prototype objects in this structural. Okay, I need to find out. Maybe a request does something similar. I want to omit some properties. I remember seeing somewhere an equals implementation that doesn't care about some properties of the object, but I don't remember where. Okay, well, let's just do it in some other way. We can just remember that in order to implement data, we have to both hash and equal, if I remember correctly. Yeah, hash and equal, perfect. Okay, so we can go back to our code and say cluster back to recipient type. Okay. We can hash dot symbol. Maybe I'll get this get hash symbol. And return hash dot struct structure, and we have the name, this dot name, and also the tag is set. This dot tag, and also name, this dot name, and also this equal symbol. Import everything as equal from effect equal. Yes, equal dot symbol. And if I remember this correctly, it will accept this and that. Okay. You can just snag it here, structural provide, blah, 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 blah. Okay. You can just copy from here. This and that. Okay. This is entity type of MSG. And that is another entity type. Oh, that is equal dot equal. Okay. Well, it makes sense because we don't know actually if that is something we. Okay, so we need to ensure that first is entity type. We have this one, entity type. No, we don't have one. Okay, so we can do as we always do. We define export const entity recipient, pardon, recipient type ID type symbol key equals effect cluster effect cluster and then recipient type. And this is the key that will be used by our export const recipient type ID, which is kind of a repetition, but this is what actually is a symbol for recipient type symbol key. And we want this to be an unique symbol. And we'll put the JS doc annotations for this because we are exporting it. Okay, now we have a recipient type ID. Okay, so we can now shove that into our classes, saying that get recipient type ID equals recipient type ID. We can maybe mark that as read only. Okay, we'll come back later to this one. Okay, and also the same goes for topic type, read only. Recipient type ID equals recipient type ID. So now that we have put a type ID inside of our data, what we can do is create a function, which is basically a type predicate that will ensure that given value is our recipient type, and will the export function is recipient type that will take in a value as unknown and will return if value is a recipient type of unknown, because we don't can make any. Maybe we can just put as a type parameter a, so it's up to the user. Okay, and say return type of value equals object, and value is not null, and recipient type ID in value, and res value recipient type ID equals recipient type ID. Okay, perfect. So now we have a function that will tell us if a value is a recipient type ID. So here in our equal implementation we was about to write, we can do something like if is recipient type that, otherwise we return false. If a recipient type, and we also know now that if this is a recipient type, to check if those are equal, we will just return if this dot tag equals that dot tag and this dot name equals that dot name. Okay, and I think that's it. Oh, okay, we need to drop the get. Okay. I need a common here. Okay. Because JavaScript is dumb. Okay. So equal dot symbol will check this recipient type. Recipient type will check that there is the same type and same name. Otherwise, it's false. Okay. And I think that the same thing will go on for the topic type. Okay. And now we have an error. Where is the error? Here, because yeah, a extends. We have a violated a constraint. A should extend message.message.any. Okay. Type one because entity type and topic type have no. Oh, this is topic type, right? You're right, as always. This is a topic type of MSG, and okay, we have no build. Okay, we have no build and compile errors. Okay, so now we can write maybe some tests just to ensure that everything is fine. So, recipient type dot test dot yes. Let me snag some stuff from the other test because I'm lazy and I don't want to write code. I want my code to be just copy and paste as always. Okay, so now we have this and we want to describe how our recipient type data type works. Okay. And we don't care about this. Oh no, we actually care because in order to define a recipient type, we need to have a sample message because a recipient type is defined by a name and a schema. So import everything as schema from fx schema. Schema. Okay, this is our sample schema. And we also need to import everything as message from effect cluster message. Okay. This is our sample message. Okay. And we'll also say that we expect recipient type equals to work as expected. Okay, and we will say that we expect equals and we will declare new. We also need to import recipient type, maybe import everything as recipient type, which is what we are testing. from effect cluster recipient type. Recipient type, yeah. And we'll const user, maybe any recipient type dot make entity type. Name will be user, and the schema will be just the sample message. And we'll have also const notifications, maybe. Recipient type dot make entity type, maybe topic type, make topic type, notifications, having the sample message, and we'll also create another sample message, maybe sample2, and we'll return a string maybe instead. And maybe we'll change the property name to id2. Okay. So now we expect user to equal itself, be true. Okay, so we expect equals user and notification to be false. Okay. And we also expect just a sip of tea. Okay. And we also want to create const user to equals recipient type, make entity type for the same name, but using a different schema. And now I want also to expect that we equals user and user2 should be true. To be true. Okay. Notifications. Okay. Okay, so let's try again. Recipient type. Run everything. Okay, test passed perfectly. And now maybe we can do the same for the ashes. Expect hash to works as expected. And we need to import everything as hash from effect hash. And now we expect the hash. I thought that there was is hash. Is this the method? I don't remember. Let's see. Hash. Yes, this one. Expect hash of user to be hash of user2, the user. And the same goes for expect hash of user to be equal of the hash of user2, and we expect hash of user not to be hash of the notifications, because those ones are different. So let's try again, run the test. Okay, it passed perfectly. Okay, so this is great because now that it implements the hash and the equal interface, I remember having some point that I want to later change to take advantage of this. Okay, so let's run npm clean. Let's run everything and see that it's still building and running. npm build. We broke something. What did we broke? Everything. Oh, that's fantastic. As always. Npm build. So because no. Oh, you want an explicit return type? Okay, that's fine by me. That's fine by me. Okay. Number. And we'll return a boolean. Number. And this will return a boolean. Okay. And we now build again. Okay, now it passed. And now we'll test, then fix. npm test. But test should work because we tested before. And so that everything worked. Yeah, I think that test passed. Go, Docker, go, you can make it. Yeah, it timed out at the pass, but yeah. I don't care because now the test is in recipient type and it worked, so we're fine. Okay. I'm pretty pleased with that. That was something that I wanted to do for a long time. And now let's just check all the changes we have. Oh, we need to run docgen in order to see if that is completely npm docgen. Let's see that you haven't missed any documentation. And we have indeed. Okay. All right. We need to put the scenes and everything else over every field we had. This is not models, with is symbols. Models, okay, and here add since 1.0.0 because we are still in alpha, so we can break whatever we want, and people will scream at us. Okay, okay, and that's it. I think. Let's try again. npm docgen. Oh, you want also for the type ID? Okay, fine by me. Okay, doc succeeded. So I think that we are ready for a PR. Git checkout -b, and we'll call this use data for recipient type Okay, and we'll push this. Uses now uses affect data for recipient type and implement custom evolve and ash. Okay, perfect. Maybe oh no, maybe closes. And the issue we want to close is the number 67. Number 67. Publish. Okay. Okay, let's wait for GitHub to catch it up. Pull requests. Okay, so let's see what we want to tackle next. Okay, maybe I can share here. Okay, so we had this one, which is the CI is running. Okay, what we have next? Oh, this is low priority. This is low priority. Maybe I can start put some labels on those. This can be considered something that maybe is the discussion tag. Meditation, dependent management, manifestation, uploading. Maybe it will be question. Okay. Okay, the CI worked perfectly. So we can just we change this one. Yeah, that's fine. We added is recipient type. We added some tests. Okay. I think that we can merge this one. Merging. Perfect. Another one down into the list. Okay, so mm, I really want to tackle this one about relying on FFRPC instead of using my own trade. And the thing is that right now I have basically the two trades to the pod service. I think the pod service, yeah, this one, and the other one is the health, I think. Basically, we have two services that deal with the communication with the pods. And the thing is that right now, those one are just defining the methods. And then I have cluster node package that implements those. Yeah. Implement the pods HTTP. Yeah. But to be honest, I think that directly relying on HTTP, not really great. Yeah, it's something more low level, maybe more performant. But since now FFRPC is part of the FF ecosystem, why not just create a cluster RPC package? And instead of you having a cluster node, having cluster RPC, and all of those methods can be defined as RPC. And then the user can use whatever RPC he wants. RPC HTTP, RPC in memory, RPC workers, whatever he wants. I wouldn't care then about what happens over the wire. And that to me seems pretty a big deal. So maybe we'll start tackling that. Okay, let's move back to origin main and git pull. Okay. So I think that we can start tackling this. Yeah. I'm unsure if I want to rename the effect node package into, yeah, I think I want to rename the entire effect node package into effect RPC. Yeah. And then, yeah, because if we rename this to effect RPC, pods HTTP will become pods RPC. And then we have sharding protocol, which will be the router of the RPC. And sharding service HTTP will be sharding RPC. Sharding manager RPC. Yeah. Yeah. The more I think about it, the more I want to do it. Okay, so let's start something new interesting. Let's see something about effect RPC. Oh yeah. Welcome, Proxys. What we are building, we are basically working on effect cluster. Effect cluster is a package built over effect, and the aim of effect cluster is to be able to build a cluster of system, basically having distributed entities that live over multiple different processes, and they speak all together over messaging, and you don't care where the entity actually live. You have basically something like this. Maybe I can find you an example. Yeah, you just know the entity ID and you send messages like, we want to increment a counter, so we send an increment message to a counter named counter number 1, and the counter behavior will live whatever it wants to. So this allows you to build scalable system because you can start with a single server, with a single pod, and have all of your entities over that server. And when you start to have a lot of entities that needs to do stuff, and you don't have enough processing power on a single server, you can spin up a second server, and they will start to talk together through a shard manager. It's basically sharding. Don't know if you know about it, but yeah. And will be part of the effect ecosystem. This is in very alpha stage. And yeah, we are tackling many improvements that we want to do over the package, and we just ended renaming using effect data for a data type. And now I was thinking about renaming a package from cluster node to cluster RPC and use effect RPC instead of an HTTP server. So let's start by saying, what is effect RPC? Effect RPC is an effect package that allows you to build RPC servers and client couples without caring about basically what the wire is. You first define the RPC using effect RPC, and then there would be other packages like RPC HTTP or RPC worker or RPC browser or RPC whatever that will actually implement the messaging over the wire over the RPC. So we were looking into RPC to see how it works. Basically distributed compute through effect without having to manage all the layers around it, such as messaging, retries, etc. Yes, exactly. Messaging is built in. You will need to define your messages, but yeah, that's the concept. Yeah. For example, here node cluster node example, we define, for example, in common, this is the schema that we define for our entities. We define a counter. The counter have the ability to get the current number of the counter, and that will return the number, and will have no errors in processing that. We call increment. Increment will have no error and return nothing. We call decrement. That will decrement, no error, will return nothing. And finally, we define a counter entity, which is basically an entity named counter that handles message of type counter MSG. This is just the, say, protocol. Well, we call it the protocol. and this is the kind of messages that the entity is able to manage. And then you define your behavior for your entity. For example, here we have a very simple behavior that is stateful. It starts with the number 0, so after that's set 0, we receive messages that can be one of get current, increment, or decrement we have seen before. And for example, for increment, we increment the counter in the ref, we log that we incremented the counter, and then we exit. Same goes for decrement, and for get current, we go back as processed. It is already working right now. Maybe I can show you. Let's see. I need to spawn up few windows in order to show you how it works, because we needed multiple processes. So let's move to desktop, cluster, and we'll move to packages, cluster node. Yep. Okay, npm example, examples, sample manager. Okay, first thing you need to have a manager. The manager is basically the thing that, maybe let me increase the size of the terminal. Increase, okay. The manager is basically the server, the process that coordinates everything, that keeps track of the servers being alive and assign entities to each server. Okay, now we can start a sample manager. Okay, we see now that the server manager is loaded. And now we can start another process, maybe. This other process will be, for example, this one. Yep. We'll move into cd, next up, cluster, packages, cluster node. Okay, npm sample, sample shard. Okay, so now we start what is called a pod, basically an application behavior server. This is the process that will actually handle the logic of our counter. And as you can see, in the exact moment that I have started this process, we see things happening in both our process that we have just started and in our server that we had before. Now, basically, the server acknowledged that the pod, the client, had a request to register itself into the server. The server received the request and now registered the pod. Oh, yeah, sure. Thank you, Mike. So now, as you can see, we have the pod that started and asked the shard manager, okay, can you please register me? And registering the pod address. And now this process has a unique identifier, which is basically the host plus the port is running on. And as you can see, that triggered a rebalance. Basically, a rebalance is a process where the shard manager, this process, will say, okay, now I need to move entities over to you because we need to split even the work that we need to perform to the behaviors of the entities. He basically moved everything because it is the only server we have right now. And now what I can start is I can start another process here. And now maybe moving again, cd, desktop, cluster, packages, cluster node, npm example, examples, sample connect. Okay, and as you can see, this process now is basically sending messages and is sending messages without knowing where the entity is hosted. As you can see now, it's starting and saying a lot. Okay. Is there any consensus algo used yet as Raft? Not yet. Right now, the shard manager is one, but we are planning on using Raft indeed. So first we are moving and ensuring that everything is working with using a fixed shard manager. Better than fixed, I'd say with the fixed address. And then later on, we can indeed move that by using any consensus like Raft. Yeah. Another interesting things we can do now that the sending is working, now that we are basically sending increments to the messages, we can maybe try to start another process here. Now we have only one pod running, which is this one, and this one will have, you can see, is receiving HTTP request and sending back the results. Okay, what we can try to do is try to start another pod which will host the entities. And what will happen ideally is that the shard manager should move some of the entities from the old pod to the new one. Okay, let's try to see if we have broke something. Desktop, cluster, packages, cluster node. Okay, and I can't start it immediately because I need to give this process a different port from the previous one, because if I try to start it right now, it will fail indeed. So we have a way from reading from the environment the port. So sharding from config, if I use something like port equals, so if I type port equals 1234 and then pnpm examples sample shard. Okay, now ideally we're gonna start another application server, another pod, and what will happen is that now it will call the shard manager. The shard manager now registered that we have a new pod 1234, and ideally what should happen now is that slowly, it just happened, slowly it will start to rebalance. So slowly it's starting to move the entities from the other pod, the first one we started, to this new one. As you can see here, we just moved entities. Now we moved entities. Slowly but surely it's moving entities. And as you can see now, some entities have a slower counter, because right now the entities doesn't store anything in no database. So when they are restarted on another pod, they restart the counter. This is effectively something that you don't want in production, but it's just as an example. And now, as you can see here, the new process is processing the entities. And you see that messages are incoming in here. So this is really fancy, really handy, because when you write your code, when you write your behavior, you don't care where the entities are running. You just care about receiving messages, processing messages, and that's it. Now I effectively have two different JavaScript processes, this one, and the other one is this one. These one are receiving requests and processes them. If I move down, we'll see that. Okay, as you can see, those one are processing messages, both this one and this one. This one is the first one we started, so right now is more busy, has more entities to process. But as you can see right now, the shard manager is slowly moving entities. You can see that here, for example, we always see entity 1, entity 6, and here we have all the others. 0, 2, 3, 4, 5, 7, 8, 9. Okay. And slowly but surely, this is a setting that you can change into, oh, entity 2 just moved. 1, 2, 6. And this is a setting you can change in after cluster and tell how many entities to move each time you rebalance is in a basic percentage. And it is in order to let the server start and warm up and do not move too much things too much faster, because that's not great, because you may accidentally change too quickly the network shape of your entities. But yeah, eventually they should become almost even. 1, 2, 6, 1, 2, 6, 8, 9. And this scales forever. And if, for example, now I shut down this process, the first one, ideally, what will happen is that it should understand that the first entity died and eventually should move everything back to the first process. As you can see, it notified that there is an unhealthy pod. Okay. And now he assigned new shards, and slowly but surely it will keep up and restart again. So this pattern is really, 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 really nice. It's basically all actor model and location transparency. You don't care where the entity lives. It's so nice. It's something that changed my mind. Okay, so back to what we were doing. So now I can close everything. So we were thinking about using Effect RPC instead of providing our own HTTP server, such that later on we can take advantage of all the potential future protocols provided by Effect RPC. Let me just take a sip. So I'm not too familiar with Effect RPC, so let's try together and see how it works. Okay, so we have both RPC and RPC HTTP. So let's start by the second one, which has examples. Okay, let's see, we have a client, a router, and a schema. A schema because, as we can imagine, messages of the RPC are going over the wire, so indeed we need a schema. We have here a user. Oh, and then we extend rpc.stream request or tagged request. Okay, that's fine. And this one, I think, are the requests that your RPC server can handle. And then we have a client and a router. Let's start by the router. Okay, the router basically handles, okay, the messages and replies, okay. And this is the user router, okay. And then it creates the RPC server by saying the router post RPC to IP, okay, to IP HTTP, and then we have the router. Okay, http.serve, we serve with the middleware, with log address. Okay, I see, yeah. So I think that maybe the first thing that we should do is start defining our messages and our router. Okay. So let's go back to the code. Okay. Packages. Cluster node. First thing we'll do is add a dependency over cluster RPC. Maybe before doing that, we can update all the packages. Yeah, that would be nice. Yeah. Oh, 306 just released. Okay. So why not? Let's upgrade first. Okay, so effect 304 in JSON. Okay, will become 306. Yes, please. And the schema 66.9. Okay. 66.7 will become 66.9. Yes, please. And then platform node, we need to update this as well. 476, yep, two patch versions basically. And effect platform .6, yes, .6. Okay. This is basically just bookkeeping. Okay, and I think another dependency I have and is not listed here is effect RPC. Yes, here it is. Which is used in the example app at the moment. Catch RPC, and the latest one is 30.11. Okay. Replace. Perfect. Okay, so now npm install. Okay, and hope that we didn't break anything. Okay, so install worked. So npm clean, npm build should work. Oh, what did we break? What did we break? Let's see. What did you break? Maybe npm check. Let's see what break. Oh, a lot of things we break. Yeah, this is just because. Sharding of time unknown. I don't understand. Let me just reload. Oh, okay. Type unknown. Why are you unknown? What? That's odd. Key set is a set of pod address. Key set is a set of pod address. This should be an pod address, right? Why don't you understand? This is a pod address. Maybe we are not on the right version of TypeScript. Let's see. We are on 5.44. Yeah. And maybe they just moved to, let's see, for example, effect. TypeScript. It's in the root package JSON, maybe? TypeScript. Oh no, it's 5.4.5, so we should be okay. But why don't you understand that this is a pod address? Let's try to break it into many parts. Okay, const a. Okay, this should be a hash set of pod addresses, and that's fine. And this should be iterable, right? Yeah, iterable of pod address. I think that the problem is that it's making some mess with the signatures. Yeah. Just moving it around, fix the issue, yeah. Those damn TypeScript overloads, yeah. Yeah, the thing is that the type of pod has become unknown for no reason. The data first version infers as unknown. And if instead I use the pipeable version now infers correctly. Yeah, that's what yeah, no infer, yeah. I am on 5.4, I think. Let me check. TypeScript. Yeah, 5.4.4, I think. Yeah. Yeah, but I'm fine. To be honest, it's even more readable if I use only the pipeable version. Yeah. Let's see if other there are other parts where this is an issue. Yeah, that was the only part in the entire code base. So the for each signature was the only one having the issue. Yeah. Build. Yeah. I thought maybe I will try that. I just want to see, yeah, it worked. Okay, so maybe we can update everything to 5.4.5, maybe fix something. Okay, so I have, let's check it out. TypeScript. Here's the 4.5 here. Okay, that goes. I need to understand still why, if I told you to exclude node modules, you are still showing node modules here. Also, if I will roll back to no info to use the custom one. Yeah, I saw that yesterday. Yeah. So maybe that will also fix it. Okay, so fifth of 5. And I should have no more instances, I think. Yeah, that's the only part. Okay, so let's try again. pnpm install. Okay, and let's try restarting TypeScript server. Where was the thing? The shard manager. Yeah. Cluster, shard manager, internal. Yeah. Shard manager. It is. Yeah, here. Okay. Let's try to put it back how it was before. Here. And restart the window and see. No, seems like same issue even with TypeScript 5.4.5. Yeah. FX should be already be updated. Should be 3.0.5, I think. Let me check the package.json, but should be already the latest one. Yeah. 3.0.6. Sorry, not 5, 6. Yeah. Already latest one. Maybe it's also something going on with the cache. Let me just clean and npm clean. Okay. npm build. Yeah, it's still failing. Okay. So let's be a good citizen and report bugs. So for now, I'll move this one in here. Okay. Let's try to create a minimal repro, something like repro.ts. Okay. Import everything as hash set from effect hash set const a equal hash set parameterable, and we'll say something like a b c, and then we'll do something like const b equals pipe a effect dot for each, and we'll do something like effect dot void. Okay, and here is working. Oh, this is the pipeable version. Yeah, is expected to work, but here if I do C and if I use the data first version, and this should infer as a no, ideally. It was working. It is working with this. Oh, maybe it's not an issue. Yeah, but it was inside. Let's try with something more plus pod address. Oh, maybe it's not just that. Is that I also had other things inside the pipe. So maybe I need also to put in the for each. Oh, map chunk dot from iterable. Yeah, I think that is this one that. Yeah. I think that it's this one that make it. Uh, yeah, this works, and this one shouldn't. Hmm. Oh, what is actually the issue? I think it is having I said not from iterable, and if I move this one, oh, we also had concurrency inherit. Maybe it's this one because that will trigger a different pod address. Yeah. Mm. Let's try snagging this one. But this is an affect adapter, not pipe. So yeah, maybe it's inside affect adapter. Yeah. Cause test equals affect.gen function. Oh, you were able to reproduce it. Nice. Effect for each of hash set union. Yeah, wanna try that. I just didn't understand if it was me or something else. See the app. So basically I did something like effect for each hash set union, and we had hash set on make new pod address a hash set dot make new pod address b, and then we have the method n effect dot void. This is unknown. Yeah, this is unknown. So the thing is related to hash set dot union, right? Yeah, it's hash set dot union that screws up everything. Yeah, that's odd. Yeah, that's odd. Okay, so back to what we were doing. Okay, for now we will move to the pipeable one, which also makes more sense because we were already inside some pipeable. Yeah. Also, ideally, this one should not be required anymore. So the button, this was related to, yeah, except chunk. Yeah, this one ideally should be removed anyway. Okay, so back to where we were. Hello, and sorry. I actually done a bit of Scala effect system before, and I feel it's complicated. How's your experience with FFTS? Okay, so I fell in love with FFTS about 3 years ago, almost 4 years ago. And the thing is that Scala effect system, I don't have any experience with Scala, but I've been orbiting through this Scala world. And the thing is that I think that in TypeScript, it's way, way, way simpler than in Scala because in the way the language works, the way TypeScript works, make it even easier. Uh, I've read people comparing Scala 3 to TypeScript, saying that they are more similar than it was with Scala 2. But yeah, my experience is very, very, very great. And you don't need to learn a lot about effort to get started with it. Sure, if you learn a lot about it, you can get almost everything about it from it. But yeah, to start with effect, you just need to know few operators, very few, 4 or 5 methods, and start with those. And I can assure you that I have a production app I built and shipped, and this started by using, I think, 20 effect methods, nothing more. And then 1 year after, I started improving that. But yeah, you can start using effort with knowing very, very few methods. My personal list of effect methods you need to start with, maybe I can show you something like methods. Yes, okay. Let's say that import ht as effort from effect. You start from something like effect.succeed, true. That just creates an effect that will always succeed with the value of true. And then you start tackling the error channel using effect.fail, wrong user, for example. And this is the second method you're struggling to, and you see that it will never succeed, but will fail with a string error. And then you start doing, okay, but those are pure values, so how can I actually use that? And inside your code base, you may have synchronous function, like for example, effect.sync, something like math.random. Okay. And this is an effect that every time it's evaluated will return a number. And this is the first kind of effect you will try to introduce into your application. But the most one you will use is something that is async, like something effect.try promise. And we'll try to run a promise, something like fetch blah blah blah. And we'll eventually catch the error and maybe translate the error in something like a string. So now we have an effect that when run will return a response and then have a string as an error. But maybe the other operator you will use is, okay, now I have all of those effects. How can I combine them? So you can start building your first program using effect.gen, which is just basically a replacement for async await. And you can say maybe const response equals yield star, and you yield a scene that you defined before. And now you see that this response is the response, and then you can build and go on. For example, you can do something that takes the response and get the JSON back or whatever. This is the first method you will use. And I can assure you that you can build an entire application by just using that. And that's it. Effect in 3 minutes. Nothing more. Oh, also, if you have, there is a language function. Let's see. Let's also say something. Async function. That's wait. Fetch. Okay. There is also language server plugin that ideally, if you have an async function, you can rewrite to affect with gen with failures. And this is the same code that will try to use effects. And now you can see that this will return an effect with void because we didn't return nothing, and will also automatically put for you tagged errors, error number 1, which you can then rename or change whatever you want. And yeah, this is a quick way to get started with that and slowly adopt effect into your code base. You start with these methods and you will have initially a lot of try promises and run promise, which is the way you actually run an effect, and then slowly start incorporate effect into your whole code base. Okay, so back to our effect update. We run install, we try to build, maybe pm clean before. Okay, pm build. Let's see if we have other errors. Okay, indeed we have other errors, but those are in this file that I need to delete. Move to trash. pm build. Okay, now it's building. Now we maybe didn't fix, and then we test. pm test. Okay, seems like nothing has broken. Let's just wait for the test to complete while I sip some tea. So are you guys already using Effect? Or are you looking forward to start using Effect in some of your project? Really interested in hearing from you. I have few Effect projects out there. I think that I have almost 5 production grade Effect projects. Yeah, but they are a lot of there are a lot of lines of code in those. So yeah, the oldest one is 4 years. Yeah, this timed out. Okay, that's fine. The oldest one is started 4 years ago, as is a warehouse management application, and has all of the front end using Effect. And now we are starting to rewrite. We are starting to analyze how to rewrite the backend from C# to I am proposing using Node, and potentially now we will start using Effect also on the backend. But yeah, it's something that I'm still trying to convince people out using Node and etc. because my company, most of the backends people are .NET people, so moving them from one language to another could be something quite more difficult. Okay, so let's see what we have changed. We have changed our package JSON. Okay, our log file I've changed indeed. Here we have changed dependency. Here we have a temporary workaround for that issue. And here, okay. 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 So git scout branch date effect 306. Okay. Update effect Meet. Yes. Publish. Okay. I'm gonna create a pull request. Maybe pull request on effect cluster instead of the effect code base. Here it is. Compare pull request. Update effect. Nothing more to say. Let's see. Oh yeah, you're right. GHPR create minus F. Yeah. Yeah. Also, I should use. I have LazyGit, which was introduced to me by Daphne, and yeah, it's actually great. But yeah, I need to start thinking more about that. I always learn new thing and then completely forget about that. Yeah, it's basically for people like me that don't know almost nothing about Git, and this little Git interface is very very great because it's something like a CLI interface. You can click around things and see and have your branches and whatever you want, and then you can then investigate your branches and whatever, and you can create new branches and push and do whatever you want from here. And yeah, sample. We'll kill this data fact. This is the one I'm working on right now. Yeah, everything passed. So splash and merge. But yeah, I need to start using the GH CLI that will also delete the branch once it created the pull request. Yeah, that's so great. Yeah, I need to move that. Okay, let's move back to the main branch. Okay. Okay. With pull, everything up to date. Okay. So I'm starting to run out of time, I think. Yeah. It's what time is it? Yeah, it's almost lunchtime. So yeah. I think that for now I will close the stream here. We did up some cleanup today. It was a pleasure speaking with you guys. And today we accomplished 2 PRs, I think. Yeah. Yeah, we updated the effect. We used the effect data. We showed the effect cluster to other people. And yeah, so hope you had some fun. Thanks for joining in. And see you soon next time. Bye bye.